Eijk. Senior project is snow tracking system, and then Dubois, Theo, and Eijk. Our advisor is Dr. Bates. So our goal is to design a snow traction system that outperforms conventional snow tire chains. Currently, snow tire chains have design limitations that make them hard to put on and move. They can be noisy, and they have to be purchased to match the exact tire size.
Snow chains can cause accidents. The chain can wrap around the drive axle of the vehicle if it's not tight enough. So after driving for a short distance, they must be checked and tightened again. If people forget to remove the snow chains, they can cause the vehicle to slide when braking. In order to know which is the right fit of snow chains on tires, the Society of Automotive Engineers has created 3 traction classes. Class S are for vehicles with restricted wheel clearance, Class U are for vehicles with non-restricted wheel clearance, and Class W are for light truck components.
Our design objectives include the design of the vibration damping system, as well as the tread face pattern design to provide extra traction for the system. In addition, we want to design a variable length deployment system to match the diameter of any kind of tire that offers the same traction as a regular snow chain and is made of durable, eco-friendly material. Our design alternatives that we've created employ a linear actuator for variable length. They can be implemented onto a static car with replaceable tire padding. Designed to match the shape and diameter of any tire, they can withstand heavy stress, strain, and high torque, and with an outer rough surface that meets the ground to provide traction.
This is our first design alternative. As you can see, the white component, it will grip to the tire treads. It will have a pattern to give better traction in snow or ice. It'll adjust to the size of the tire by a linear actuator, which will be operated by either a hand crank or an electric motor. And it'll stay in place by the compression force of the linear actuator on the tire. This is a simulation and how it would adjust to the tire size.
Our second design alternative will have another adjustment system added on in order to provide a larger surface area for traction. Both systems will have a hand crank device. We are in the process of designing a type of gearbox that will fit our inside clearance and provide the right amount of traction. Our outside paddings will have a rubber shark shape design, and our inside paddings will have cleats.
Here's a brief animation of our second design alternative. Our components that we've developed will encompass a mechanical linear actuator using a fixed worm gear and a series of rotating worm gears and a planetary gear set. As the fixed rod rotates, it will accelerate the linear driver forward, creating the variable length, and it will be composed of aluminum T66061 material. Our chassis will house the hand crank and the electric motor system, as well as the linear actuators, and is composed of the same aluminum material to provide a steady, durable fit. And lastly, the padding. We want to mold it after a shark skin, so that it's rough on one end and smooth on the other end, and that can hopefully grip to the concrete surface and provide extra traction.
Our padding surfaces, we are considering to use natural gum rubber. It's an eco-friendly material made from the sap of trees. It is also in high demand for automotive applications and military because of its high durability and elasticity when under stress. T66061 aluminum is used on the rims of cars. We are thinking of using this aluminum on the arms, but our final decision will be based on which aluminum has the most strength and low cost. For our chassis and paddings, we are debating on using ABS since we're only going to use it to test which material is better to the surface, and it's also easy to machine and recycle.
Plan on doing a stress, strain, fracture analysis along with the thermal study to determine if our material selection will indeed perform as intended in the cold environment, since cold temperatures tend to affect material properties. We will also do an impact and shock study to determine if the structural integrity of our system in the case of a rod encounter on the road or a pothole. And we will obtain a safety factor from this, and also we will do a simulation of our tire width component on it, on a snowy road to determine the contact area of the patty and see if it's enough traction provided by it.
These are some of the additional simulations and studies that we want to perform. We found a SolidWorks simulation program that lets us simulate the effects of snow on the tire surface. So we want to measure the amount of traction that's produced over the surface. Additionally, we want to take an abrasive wear testing on our patterning material and on the material itself to see if it can withstand the amount of high torque and strain that will be produced by a car, and in addition to various other life experiments. Our motivation and goals include an improvement and expansion of the conventional system and help a vehicle traverse difficult terrains easier. We want to include safety to avoid damage to vehicles and roads, and we want to ensure that our system is quick and easy to install.
This is our work breakdown. We currently finished the design phase. We will proceed on to simulations, and then we will verify the simulations with pancake collections. Once that is done, we will proceed to manufacturing. It will consist of assembly, testing, and then finally verifying our test results with simulation results and calculations. We plan on finishing early in October. We are going to use the summertime to advance the project as much as we can. Hopefully we can finish earlier than that. Thank you.
Couple of questions. Have any of you ever put a set of chains on a tire?
No.
It's an interesting thing to do in the middle of the winter when it's icy cold. Number one, the people that use this the most are trucks. I grew up in New England and cars do it, but snow tires, but trucks still use chains to get traction, and they're brutal on it. I'm not sure aluminum is going to stand the strain of the truck. Maybe if I put it on a Porsche 911, it might be all right. But you're going to have to make this really tough, because it's a tough. Not only is the people putting it on tough, you know, they just got a bigger wrench, and it doesn't work. And secondly, you're not just going to be in snow. You're going to be snow, chunky ice, stuff that's like rocks going over there. So you really need to consider, you know, a really, really tough environment for this kind of thing. And how you're going to stop it from being brutalized by the operators if you want to make it, you know, a viable thing. I think it'd be great because it's a miserable job to put chains on in the middle of the winter outside. And these trucks stop on mountainous passes, and while they're right out in the road, they're putting these chains on. So if you had something that was automated, it would slide on and do it. It just has to be, at least in my perception, something really, really rugged.
Is your intent to put this on front wheels and back wheels?
I would think only back wheels. You know, that's where traction comes from. But it would help with the handling completely in the front wheels as well.
Wait, but when you do your analysis, make sure that if you intend to put it on the front, you gotta remember those tires rotate, and you've got different kinds of torsion. This is not symmetrical around the side of the wheel. So that would have to go into this. The other thing is, have you looked, or make sure you look into how much additional torque this is going to put on your differential, to make sure that you don't shear drive shaft, because you now doubled the size of the wheel, maybe, or the effective wheel. So the good news is it works. The bad news is it blew up my differential. So I would suggest you look at that. I again agree with the question on using aluminum and ABS for this application, because I have a feeling that they're not going to survive, but you need to do the work there. And that's all I have. Thank you. I guess I do have one more. I'm sorry.
Go ahead.
We are in South Florida. How are you going to test this?
Yes, we have a few ideas. We're thinking of even trying it with sand, because we have no snow available here. But also, we could travel to a place that has snow and test it there.
We were thinking about designing some of the padding to be able to fit much more sandy terrain, and then trying it out.
Yeah, just note that you're doing all your testing in August, September, October, you're not gonna see snow
Yeah.
anywhere till February, because that's the world we live in. It was,
So a comment on your, you can also test it at ice skating arena. You can do this on Bunny, so you can test it in that environment. Just talk to the manager and you can use that.
We were thinking about that,
Yeah,
just renting out an ice skating rink and.
Exactly. Simulate the environment.
Yeah.
Well, Ready Ice will bring a truckload over and shave it for you.
Yeah.
They do it for kids that have snowball fights, you know, so you could definitely, you know, I don't know what it costs, but a few $100s, they'll bring a truckload of ice and just shave a big pile of it for you. You probably get the testing done before it would all melt anyway.
Yeah.